Okay, this is the 9.1 mole-to-mole stoichiometry problem solutions. So if you were struggling with mole-to-mole ratio and you logged into the Zoom session and had some questions and maybe you got them answered and then you just kind of forgot about it, or maybe you just forgot about this assignment in general and you're like, oh crap. Remember, you will be docked points for lateness, but I'm just going to give you a solution and work through problems for your benefit. So first question is, we get this equation, mercury oxide decomposes down into mercury and oxygen. That's supposed to be a plus sign. I just noticed that. Sorry. Write all possible mole ratios, and there are 6. So remember mole ratios. Just look at the relationships. I'm just going to use purple here. So the 2 in front of this HGO is for moles. So I'll just start there. 2 mole HGO. Let's just say I want to go to Hg, mercury, on the other side. There's a 2 there, so it would also be 2 mole Hg. But then I can flip it. So there's 1 mole ratio, 5 more to go, so I can flip it. 2 mole Hg. On the bottom, 2 mole HGO. So 2 mole ratios down, 4 more to go. Let's take a look at the relationship between HGO and oxygen. Okay. Oops. 2. All right, I'm just going to start over, sorry. 2 mole HGO over, there's no number in front of oxygen gas, so it's just going to be 1 mole O2. Okay, but then I can flip it, and I don't trust myself, I'm not going to be able to fit it there. So I got 1 mole oxygen gas over 2 mole HGO. All right, 2 more. The last relationship is between Hg, whoops, and I totally missed that, and O2. So I have 2 mole Hg over 1 mole O2, and then I got to flip it. 1 mole O2 over 2 mole Hg. So there's the solution for problem 1. Okay, second, you must show your work for the following problems. Do not forget your units. Calculate the amounts requested if I am given 1.34 moles of hydrogen peroxide H2O2. Completely reacts according to the following equation. Hydrogen peroxide breaks down into water and oxygen gas. So the first step is figure out what you're given. In this case, we are given 1.34 moles. So I'm going to start with that. 1.34 mole of H2O2. So second step is, this is a balanced equation, by the way. Second step is figure out what mole ratio you want to use. So I am in H2O2. I know that's going to go on the bottom. And if I look, I have a 2 here. So 2 mole H2O2 is going to go on the bottom. What goes on top is what you are trying to get to. So it says moles of oxygen. Now you're going to look at oxygen. So 1 mole of O2. So 1.34 times 1 divided by 2, you punch that in your calculator, should get 0.67 moles of O2. Remember, hydrogen peroxide, the reason why it's on the bottom is it's going to cancel out. So you're left with moles of oxygen gas. All right, moles of water formed. So we're just going to use what we're given, in this case 1.34 moles of H2O2. Set up my conversion factor. I'm in H2O2, so that's going to go on the bottom. If I look at my chemical equation, it's a 2, so it's going to be 2 mole H2O2. What am I trying to get to? I'm trying to get to water. So look at the chemical equation here. Oh, it's a 2. So 2 mole H2O. So 1.34 times 2 divided by 2 equals 1.34 moles. Of H2O. Remember, hydrogen peroxide, H2O2 is going to cancel out. All right, final question. Calculate the amounts requested if 3.3 moles of iron oxide completely react according to the following equation. Iron oxide plus aluminum yields iron plus aluminum oxide. So, how many moles of aluminum are needed for this reaction given 3.3 moles? So first off, I should probably say, is this chemical equation balanced? Yes, it is. All right. So then after that, you start with what you're given. 3.30 moles of iron oxide. Set up my conversion factor. I'm in iron oxide, so that needs to go on the bottom. And I didn't give myself enough space. That was stupid of me. If I look here, that means 1. So really this should, I'm just going to, sorry. Can't believe I did that. Okay, so 1 mole of iron oxide. So then what goes on top? The compound or element you're trying to get to, in this case, aluminum. So I look at my chemical equation, there's a 2 there. So I'm going to put 2 mole aluminum or aluminium, however you want to say it. So 3.30 times 2 divided by 1 gives me 6.6 moles of aluminum that is needed for this chemical reaction to start, or to completely react. Okay, moles of iron formed. So I'm just going to assume this is what I'm given. So you start with that. I'm in iron oxide. That's what's going to go on the bottom. I look at the chemical equation. It's going to be a 1 mole iron oxide. What goes on top? The element or compound you're trying to get to, in this case, iron. So I look at my chemical equation. There's a 2 there. 2 moles. Iron go on top. So 3.30 moles times 2 divided by 1 is also 6.6 moles of iron that will be formed from this. Last one, moles of aluminum oxide formed. So you start with what you're given. Set up your mole ratio. I'm in iron oxide, so that's going to go on the bottom. It's going to be a 1 mole iron oxide. What goes on top? The element or compound you're trying to get to, aluminum oxide. Here's aluminum oxide. It's a 1 mole aluminum oxide. 3.0 times 1 divided by 1. 3.30 moles of aluminum oxide. So hopefully this video kind of clarified some things or assisted you and maybe understand a little bit more about mole ratios. These are very, very simple stoichiometric problems. So, be prepared. We're going to kind of step it up here in a little bit.